Assalamu alaikum dear students. So let us start with the properties of the colloidal solutions, because already we have seen now the purification process. So now we are going to deal with the properties of the colloidal solution, because it is having different properties which we are going to learn today. So the first property is colligative property. Dear student, colligative property depends only on the number of the dissolved particle, that may be molecule, ions, small or big in large in size, in the solution, and not their identity. Let me tell you, we are not describing which iron is present. Like suppose we don't talk about that sodium is present or your chlorine is present. We are irrespective towards the particular type of it. We are depending on the number of the particles, that is molecule or the ions. Okay. So that is very important one. Especially osmotic pressure is going to depend on number of particles, vapor pressure, lowering, boiling point elevation, freezing point depression. All these are the which we can say these are the properties. These properties are totally dependent on the number of particles. Okay, then we are going to have this all this particular whichever is described over here. It is present, it is there in your lesson number 2, solutions. In this we are going to talk about that in detail. So when you're going to come across the formulas over there, you will come to know that directly it is depending on the number of the particles. When any property is depend on the number of the particles, such properties are known as colligative properties. It means osmotic pressure, vapor pressure, boiling point, freezing point, all these are the colligative properties. So when we talk about the colloidal solutions, that is also the colligative property. Okay, next one, Tangle Effect. Dear student, you are familiar. Tangle Effect is a phenomenon, scattering of a beam of a light by the medium containing the small dispersion particles, for example smoke, dust in the room, which makes a visible light beam entering a window. The effect is named after the 19th century British physicist John Tyndall, who first studies it extensively. So dear students, we are knowing the Tangle effect, that it is simply the scattering of the beam of the particles. Okay, when we pass the beam of a light, the particles are scattered. When the particles are scattering the light, it is known as the Tangle effect. We have a number of examples of this particular, and when we are going to see the applications, you will come across more examples also. Okay, so Tangle effect is almost seen in the colloidal solutions, because your colloidal solution is heterogeneous. Homogeneous solutions does not show the Tangle effect. Only the heterogeneous is able to show you the Tangle effect. Okay, so we talk about the colloidals. Colloidals can show the Tangle effect, and the suspension can also show the Tangle effect. So that is what we are knowing. Dear student, let me tell you, the Tangle effect is as it is observed over there in your this particular chapter, that is in your colloidals also. So we need to know that what is the main thing because of which, what is the main thing on which your this property is going to depend. Okay, a common example of the Tangle effect can be observed in cinema. You can observe the projection beam all the way from the projector to the screen due to the scattering of a light by the dust particles. I hope this is you have observed many a times. You know, early in the morning when we open the window and when we allow the sunlight to come in the room. Okay, at that particular path you are able to see that particles are moving. Those are the dust particles, and we can say that effect as a Tangle effect. So dear student, you are able to see over here. For the Tangle effect to be observed, the following condition must be satisfied. Now dear student, this is very important to note down. There are two particular conditions which are needed to be satisfied to observe the Tangle effect. Number 1, the reflective index of the dispersed phase and that of the dispersion medium must differ appreciably in the magnitude. What does it means? आपका जो dispersed phase है, मतलब कि जो particle, और आपका जो dispersion medium है, for example dust particle is your dispersed phase and air is a medium in which it is flowing. They should have a magnitude of the difference. Different magnitude should be there. If there is no different magnitude, it will be very difficult for you to observe the Tangle effect. This is the first point. Second point, the size of the dispersed particles should be comparable to the wavelength of the light used. आप जो लाइट यूज कर रहे हो उसकी जो वेवलेंथ है उसके साथ कंपेरेबल होना चाहिए क्या, आपका साइज ऑफ द पार्टिकल. ओके, सो दिस आर नीडेड टू बी सेटिस्फाइड. द थर्ड प्रॉपर्टी इज कलर. Dear student, the color of the colloidal solutions depend on the wavelength of the light scattered by the dispersion particle. आपका जो पार्टिकल है वो कौन सी वेवलेंथ की लाइट को स्कैटर कर रहा है उस पर डिपेंड कर रहा है. मतलब कि आपके पार्टिकल की साइज कितनी है उसके हिसाब से आपको वो लाइट दिखेगी. फॉर एग्जाम्पल, व्हेन वी टॉक अबाउट द फाइनेस्ट गोल्ड soul is red in color, but the size of the particle increases, it becomes purple, then blue, ultimately golden. So depending on the size of the particles, you are able to see the different colors over here. The color also depends upon the manner in which the light is observed. For example, sulfur soul may be colorless, faint yellow or deep yellow in the reflective index, and reddish in the transmitted light. So we can say that these are the different examples over here. To cite another example, a mixture of the milk and the water appears blue when viewed through the reflected light and red through the transmitted light. So dear student, कौन से एंगल से देख रहे हो आप, कौन से एंगल से, वो रिफ्लेक्टेड लाइट के एंगल से देख रहे हो, ट्रांसमिटेड से देख रहे हो, तब भी वो कलर चेंज देगा. ऑल्सो साइज के हिसाब से भी वो कलर चेंज देगा. सो दिस आर द प्रॉपर्टीज possessed by the colloidal solutions. There are other important properties also, but that we will be discussing in our next video. For example, we are going to talk about the Brownian motion. We are going to talk about the electrophoresis, coagulation. These are still the properties remaining which we are going to do in our next video. So in this video we have described the three properties: colligative properties, Tangle effect and color.